Okay, this lecture is going to cover our final topic in Module 5 on memory in Chapter 6. So let's get started. So, how do we define memory? It is the process by which we encode, store, and retrieve information that we receive from our environment. So, our memories are a collection of information and experiences that you have been exposed to throughout your life that are stored in the brain to be retrieved at a later time. Now, there are three distinct processes that occur with memory: encoding, storage, and retrieval. So, the first process, which is encoding, is the initial recording of information. So, this process can be seen as analogous to something like a keyboard on a computer, where information is essentially taken in and recorded, like when you're typing something out. The second process that occurs with memory is storage. So, this involves saving the recorded information for future use. So, this process, again, if we stick with the computer analogy, this process can be compared to that of a hard drive on a computer. So, it's how the information is stored. And the third process of memory is retrieval. This is the recovery of previously stored information. So, again, this process can be compared using the computer analogy. You would compare the retrieval process to the displaying of information on the computer screen, right? So, that information is typed out on the computer, that's encoding. It's stored or saved in the hard drive, that's the storage part. And then if you need to retrieve that information, you would open up that hard drive and pull up the file you need. So the retrieval part of memory. So they often use this analogy of between a computer and memory just so you can get an idea of how these things are functioning. Now, in order for you to retrieve or recall a memory, it first has to be properly recorded and stored. If this doesn't occur and the information isn't stored correctly, you won't be able to remember it at a later time. Same thing if you think about this with the analogy in the computer. If you don't type out the right information, if you don't hit save, right, the computer doesn't save the information. And then you can't find it later. You can't pull the file up because you either didn't write down or type out the correct information or you didn't save it correctly. So, all three of these processes, when we're talking about memory, they're necessary in order to recall that information from memory. So, if a step is missed, you won't be successful in recalling a memory. Now, the question is exactly what information is stored in our memory? How is it stored there? And then how is it later retrieved? So, the three system memory theory proposes that there are actually three separate memory storage systems, and information has to sort of travel through these storage systems in order for it to then be remembered, right, as a memory. So, the first storage system in this theory is the sensory memory. So, this is the initial or momentary storage of information. And unless these memories or this information passes on into the short term memory storage, then these memories will be lost forever. So, sensory memories are very fleeting, they're very quick, and if they aren't transferred to short term memory, they're immediately forgotten. The second storage system, according to this theory, is the short term memory. So, memories stored here last around 15 to 25 seconds, although these memories do last longer than sensory memory. But again, if these short term memories are not transferred to the long term memory, then they too are forgotten. Okay, so you have sensory memory, these last for about a second and then they're forgotten unless they're transferred to short term memory. Same thing with those memories in short term memory, they only last about 15 to 25 seconds. unless they're transferred to long-term memory. So finally, of course, the third storage system is long-term memory. This information is stored here on a relatively permanent basis. So once these memories make it to the long-term memory storage system, most likely you will be able to retrieve them at a later time. And we're going to get into the details of each of these storage systems in just a minute. That was just kind of a brief overview of the three systems according to that theory. And here's sort of a picture demonstrating how the three system memory theory works. So again, you have sensory information coming in from the left. So this is any sensory information that you're gathering from the senses, right? So it can be visual information, auditory, um, olfactory, right? Sense of touch. So any sensory information that you're getting from your sense organs. And like I said, we typically forget these memories within 1 second unless they're transferred to short term memory. Then, in the short term memory, these memories are forgotten within 15 to 25 seconds unless they're repeated during rehearsal. So, if repetitive rehearsal occurs, and the memories can be transferred to long term memory. Finally, memories are transferred to the long term memory, and we will be able to recall them at a later time, as long as you go through something called elaborative rehearsal, which we're going to go into in detail in just a moment. But basically, you have repetitive rehearsal, which occurs in short term memory. This is just where you're repeating the information over and over and over again so that it can be remembered and transferred to long term memory. But elaborative rehearsal is more active. So, this is when you're actively doing things to commit the information to memory. And we'll talk about what those are in just a moment. Now, there are two different types of sensory memory, which remember, those are sort of snapshot memories that are forgotten within 1 second. So, that is the first stage within the three theory, the memory theory. Okay. So the two parts of sensory memory, we have iconic memory and echoic memory. Now, iconic memory is information that is received specifically from the visual system. So we're talking about any visual stimuli that you can see. Whereas echoic memory is information that is received from your auditory system. So any sound or auditory stimuli, okay, anything that you hear. So these are the two types of sensory memory. And these memories are recorded with a high amount of accuracy and precision. So, sensory memory can actually record almost an exact replica of the sensation that you're exposed to, whether it's a sound or a sight, seeing a lightning bolt, seeing um, I don't know, a flash of light, from a camera, or a sound, a specific sound that you hear, whatever you're exposed to. These sensory memories are actually highly accurate in terms of recalling what it was you saw or heard. It's just that they only last for a very brief time, typically 1 second or less. There's snapshots. And what's happening is um, when one snapshot is taken, other snapshots are being taken as well, and those replace the ones that were taken right before it, right? So you kind of, it's a use it or lose it type thing. Either you're going to save the snapshot if it transfers to short-term memory, or you're not, and that memory is lost after a brief moment. So then, if those memories are transferred, we have short-term memory. So again, as I stated before, this allows you to hold information for about 15 to 25 seconds. Now, the specific processes that are involved with transferring the sensory memories into short-term memories aren't exactly clear. Theorists on memory are still sort of figuring out what processes are involved from getting the memories from that short 1 second snapshot to the short term memory where they can be rehearsed and passed on. But researchers have identified that the specific amount of information that can be stored in short term memory is about plus or minus 2 of 7 items, which basically means from anywhere from 5 to 9 items can be remembered in short term memory at a time. And they call these things, they can also be called chunks of information. So, chunks are a group of separate pieces of information, but they're stored as a single unit in the short term memory. So this can be a group of individual letters or numbers. And like I said before, it's plus or minus 2 from 7. So that's the number that theorists are saying we can remember with our short-term memory, anywhere from 5 to 9 letters or digits or chunks. Okay. So you might be able to memorize 7 numbers in a row or 7 letters in a row. But this can also consist of larger categories. And this is when we break them up into chunks or groups. So let's say you have 21 numbers. And if you can imagine, if all of these numbers were just strung together in one long line as 21 individual numbers, right? So not chunked together like you see them here, but just 1, 2, 3, 4, 5, 6, 7, 8, 9, all flowing into each other, 21 numbers. That is quite difficult to remember. You would most likely not be able to glance at that and then remember all 21 numbers. But um, if you group them together, you're more likely to remember them. A good example of this is with telephone numbers. So nowadays, most people don't memorize telephone numbers of their friends or family because they're usually stored in your phone, right? But we used to have to memorize them all. We didn't even used to have cell phones. And even when we did, they were kind of just a hassle to use. It was easier to just type in someone's number on the cell phone. So you memorized everyone's cell number. And also, most people had a landline, right? Not a cell phone. So you would be dialing that as well. So rather than memorizing, 10 individual numbers, especially when you're first learning someone's phone number or someone's giving you their phone number, you would memorize it in 3 chunks or groups. So the first 3 numbers is the area code of the phone number, right? That's the first chunk. Then the first 3 digits of the actual phone number would be the second chunk. And then the last 4 digits of the phone number would be the third chunk. Okay. So placing the numbers in chunks or groups is easier than trying to remember a string of, for example, 10 individual numbers like you would have in a phone number. And it's the same with a large group of numbers like we have here. So, like I said, there are 21 numbers, but if you split them up into 7 chunks of 3, you're much more likely to remember them than if you're trying to just remember a string of 21 individual numbers. Now, typically, transferring short term memories to long term memory is achieved through rehearsal of some type. Now, repetitive rehearsal of information. So, this is where the information is just repeated over and over. So, much like when you're trying to remember a telephone number, you might repeat it to yourself many times. This actually allows the memory to remain in short term memory for a longer period of time, right? So, you're repeating that information over and over again, and it remains in the short term memory longer than that 15 to 25 seconds that it would have been there had you not been rehearsing. But with repetitive rehearsal like that, it may not necessarily be transferred to long term memory. But something called elaborative rehearsal, these techniques make it much more likely that the information will be transferred to long term memory. And there are several different techniques of elaborative rehearsal that can be used. So the first is something called mnemonics, which is something you've probably used or heard of when you're studying. These are often used in, higher math classes, science classes, history classes to remember dates and presidents and things like that. But basically, it connects the information to something else that serves as a trigger for retrieving that information. So, for example, let's say you're trying to remember Piaget's stages of cognitive development, right? So you have the sensory modal, the pre-operational, concrete operational. You might make a mnemonic such as smart people cook fish. So the first letter of each of these words corresponds to the actual correct answer of one of the four stages of Piaget's stages. So the S in smart, for example, relates back to the sensory motor stage, right? They both start with S. The P in people relates back to the pre operational stage. They both start with P, and so on, right? Another popular mnemonic is HOMES for the Great Lakes, right? So you have HOMES. You have Lake Huron, Ontario, Michigan, Erie, Superior. HOMES, right? So the first letter of each of the lakes spells out the word HOMES. I used to study this way all the time in high school. My mom was amazing at coming up with all sorts of mnemonics to help me remember things like the capitals of each state or the order of the presidents and the vice presidents, different history dates. She would come up with all kinds of crazy mnemonics, and I still remember a lot of them to this day, even many, many, many years later. So it's a good way to commit information to your long term memory. The second technique is teaching someone else the information. So when you are not only learning and trying to memorize the information yourself, but when you have to repeat it, you have to break it down. When you're teaching something to someone, think about that. You not only have to learn it yourself, you have to understand it and you have to be able to break it down so that someone else can understand it too. And often doing all of these steps can result in the information being transferred to your long term memory. Now, the third technique is testing yourself. So, whether this means you take practice tests that have been put for you online, making flashcards, taking like the practice quizzes we have on Canvas. By testing yourself on the information and repeating it, and then going back over the ones you got incorrect and testing yourself again, this is another technique that often results in the information being transferred to your long term memory. Because not only are you now repeating this information, but you're actively learning and repeating it. So you're learning it, then you're quizzing yourself on it, you're going back over the ones you got incorrect, you're quizzing yourself again, and it often transfers that information to your long term memory. And a final technique is visualization of the information. So, this actually refers to linking the information with a visual picture or image that relates to the information. And again, this most likely will result in the information being transferred to your long term memory. And then later, when you're trying to recall or retrieve the information, having that visual picture or image that has been linked to it will make it easier for you to retrieve. Now, most contemporary memory theorists do view short term memory as much more active than just being able to store memories from 15 to 25 seconds. So, researchers now look at working memory as being able to store memories beyond that 15 to 25 seconds. So, they see short term memory and refer to it as working memory. It's a memory system that holds information temporarily while actively manipulating and rehearsing the information. So, kind of how we talked about that repetitive rehearsing that can occur in short term memory. The working memory keeps that information in an active state so that the information can be processed. Essentially, what this does is it keeps that information in your memory long enough so that you can do something with it, right? Most likely, transfer it to long term memory. Now, current researchers assume that the working memory is made up of several parts containing what they call the central executive processor. And this is responsible for reasoning, our decision making, and planning. So, the central executive determines what you're going to pay attention to. So, of all that sensory information that's coming in, what are you actually going to pay attention to? And it also determines what information you're going to ignore. Okay, so that there is some information that you don't need to transfer to your long term memory. So the central executive processor sort of determines what information is important to remember and what's not. So it coordinates information from three subsystems: the visual store, the verbal store, and the episodic buffer. As you can guess, the visual source specializes in visual and spatial information, right? So that information you're getting from visual or sight and also from spatial navigation of your environment. So where things are or navigation type information. And the verbal store, of course, holds and manipulates information related to speech, words, and numbers, right? So verbal. Um, or spoken information. And finally, the episodic buffer contains information that represents a specific episode or event. So we're referring to things that happen to you in your lifetime. So getting in a car accident, your first kiss, graduating high school, and so on. Right? So you have these three sort of subsystems within the central executive, the visual store, the verbal store, and the episodic buffer. And all of these three subsystems of the working memory, they serve to as storage and rehearsal systems. So all of these are working together to store and rehearse information, right? So that again, so it can be transferred to the long-term memory. It's keeping that information in an active state so you can actually do something with it. And we're going to stop there for this part of the lecture.